So this is a study about electricity trade and CO2 emissions. I'd like to introduce a new study entitled Beyond Borders, Estimating the Marginal Emission Factor of Electricity Trade, published in Energy Economics and which is co-authored by Filippo Beltrami and Luigi Grossi, both of which are very cool guys and I really enjoyed the collaboration with them. The paper in a nutshell. We are asking what happens to CO2 when countries engage in electricity trade. The goal is to quantify marginal CO2 effects of cross-border electricity trade in Germany. We employ hourly electricity market data for the period January 2019 through December 2023. We employ a causal econometric regression framework via two-stage least squares, so essentially an instrumental variables approach. We do that because there is an endogeneity problem. On the one hand, electricity imports or electricity exports determine CO2 emissions or electricity generation by technology. But on the other hand, electricity generation by technology determines electricity prices and therefore determines electricity trade. Hence, the key idea is to instrument net exports with exogenous wind electricity generation in markets surrounding Germany. What we find is, firstly, exporting 1 additional megawatt hour raises German CO2 emissions by around 0.94 tons, which is indeed a lot. The explanation is that typically coal produces the extra electricity for export. And thirdly, omitting trade biases estimates of marginal emission factors. Germany is located in the heart of Europe, and electricity trade is large in Europe and especially in Germany. Electricity imports are an important source of flexibility. Whenever national electricity supply cannot meet electricity demand, imports are crucial. However, national CO2 accounts treat imports as emission-free at the point of use. That means national CO2 goals can be, let's say, distorted by electricity trade. And that's something we investigate further in this study. Let's investigate trade by means of a stylized example. Between Germany and France, there is an interconnection line which connects the two countries. Now a French consumer asks for more electricity. Je demande de l'électricité. And the Germans are responding. Jawohl, the electricity is coming. Ramp up the plant. And the electricity plants produce electricity and therefore additional CO2 emissions, and the electricity flows from Germany to France. That essentially means that Germany's national CO2 inventory increases, which is bad for Germany's CO2 targets. On the other hand, France consumes electricity that is accounted for as having zero CO2 emissions. Let's take a look at Germany's net electricity imports over the years from 1990 to 2024. What we see is that for most of the time, Germany was a net exporter of electricity, but then the trend reversed, mainly due to Germany's nuclear exit. During our sample period, however, Germany was a net exporter for most of the time. So we ask, what are interesting research questions? Question 1 asks, what are the marginal emission factors of Germany's net exports and national demand? Question 2 asks, how biased are marginal emission factors if trade is ignored or treated as exogenous? And question 3 concerns the policy. How should national accounting or international coordination reflect trade-driven emissions? The method we employ is a causal econometric framework, essentially instrumental variables estimation via a two-stage least squares framework. We employ hourly electricity market data for the Germany-Luxembourg bidding zone using supply by technology and national demand. We also employ cross-border scheduled electricity exchanges with neighboring countries. We construct hourly CO2 emissions from lignite, hard coal and gas combustion using typical emission factors and typical efficiency factors. We do that because such data are not available at an hourly frequency for electricity production. As a control variable, we also employ the European Dutch TTF gas price. Let's now apply some economic intuition on electricity supply via the merit order at a spot exchange and electricity trade. At a spot exchange, electricity supply in the form of the merit order dispatch, so determined by the marginal costs of each individual supplying electricity plant, meets national electricity demand, and therefore the interplay between demand and supply determines which plants are in the market and produce electricity. So the merit order sets the marginal plant and thus marginal emissions at each hour. In a stylistic figure, we can also look at electricity trade. Here, electricity exports work like extra demand for the exporting country, and on the other hand, electricity imports work like an outward shift of the electricity supply curve for the importing country. So if coal is the marginal technology during times of exports, trade raises the exporters' CO2 emissions and shifts them across the border. What is our identification strategy? The goal is to estimate the effect of electricity net exports on Germany's CO2 emissions. We include a set of exogenous control variables to rule out omitted variable bias from potentially confounding effects that also influence CO2 emissions, such as wind electricity in Germany, solar electricity, hydroelectricity, nuclear electricity, national demand, the price of gas, together with fixed effects for the hour of the day of the week, month of the year, and years. A potential threat to identification is reverse causality. Net exports essentially determine CO2 emissions, but on the other hand, CO2 emissions also determine net exports via their effect on production from different technologies and therefore electricity prices. That is why we use an instrumental variables approach. We identify the exogenous variation in net exports via neighboring wind electricity production in order to rule out the reverse causality bias between net exports and CO2. The model that we then estimate is a first stage regression where net exports are explained by wind in adjacent countries together with all the right-hand side variables that are exogenous, and in a second stage, CO2 emissions in Germany are explained by the exogenized net exports and other control variables. Let's come to the first stage regression. We employ three different instrumental variables: wind electricity production in France, wind electricity production in Switzerland, and wind electricity production in all of Germany's neighboring countries. Let's talk about instrument relevance. We find that more electricity production in neighboring countries leads to less net exports from Germany. So we identify a strong negative partial correlation between all of our instruments and net exports from Germany, which is intuitive. Moreover, and importantly, the Kleibergen-Paap-F statistic is significantly larger than 10, which points to non-weak instruments. Another critical assumption is the exclusion restriction. The instrument, for example wind in all neighboring countries, must affect Germany's CO2 emissions only through net exports. This assumption is not testable empirically, so we have to apply economic intuition. Neighboring wind electricity affects Germany only through electricity trade. Or put differently, without trade, there is no effect. Neighboring wind electricity does not affect Germany's CO2 emissions if there is no interconnection or no trade between two markets. Let's come to our primary regression estimates, to our second stage in which we estimate marginal emission factors. I now concentrate only on regression estimates of our primary regression, which is our two-stage least squares instrumental variables approach. We find that the marginal emission factor of net exports is estimated at 0.94 tons of CO2 per megawatt hour of exported electricity. This is a lot. The interpretation is that Germany typically exports when residual demand is low, so when coal electricity is the marginal technology. Why is that? Because gas has a very low marginal emissions factor compared to hard coal or lignite. So whenever a lignite or hard coal plant is the marginal technology, we have around 1 ton of CO2 emissions per megawatt hour of electricity generated. That means exports are more frequent at low residual demand, for example during the night or during the noon, when coal represents the marginal technology. We also find that the marginal emission factor of national demand of load is estimated at 0.65 tons of CO2 per megawatt hour, which is significantly less compared to net exports. When we look at alternative IV regressions, we find that other instruments, for example wind in France or wind electricity in Switzerland, come to similar regression estimates. However, they are not exactly the same. When we run a naive OLS regression, we find endogeneity bias. The estimated marginal emission factor of net exports is only 0.75 relative to 0.94 tons of CO2 in our primary regression. So this is an estimation bias of around 26%. Moreover, running an OLS regression without net exports in this regression leads to a bias in the marginal emission factor of load, which is now only 0.6 relative to 0.645 in our primary regression. So this is a bias of roughly 9%. Finally, a very naive regression without any control variables, but only having fixed effects in place, leads to meaningless results. Here we find even a negative estimated emissions factor, which is just counterintuitive. Let's apply some intuition. It said that there is a high estimated marginal emission factor of net exports of 0.94 tons of CO2 per megawatt hour, which is likely because exports mainly happen at low residual demand when coal is marginal. And this is exactly what we find in the data. We find high net exports coincide with low residual demand and vice versa. Alright, let's do a quick mechanism check. For 1 megawatt hour of net exports, which is basically additional demand, Germany on average produces 0.54 megawatt hour of lignite electricity, 0.33 megawatt hours of hard coal electricity, and 0.27 megawatt hours of natural gas. And that translates into very high emissions, 0.56 tons of CO2 from lignite electricity, 0.28 tons of CO2 from hard coal electricity, and only 0.1 ton of CO2 from natural gas. So we can summarize. An additional megawatt hour of net exports is produced mainly via lignite and hard coal, which explains the high marginal emission factor of Germany's net exports. What are the key takeaways? Net exports result in 0.94 tons of CO2 per additional megawatt hour of net export on average. So coal is typically the marginal source of production. Ignoring trade or endogeneity leads to estimation bias in marginal emission factors. And we have to use instrumental variables in order to estimate marginal emission factors for policy assessment in interconnected grids. What are the policy implications? Trade shifts where emissions appear in national inventories, so consumption-based metrics would potentially help. international coordination would be advisable. Exporters currently bear the CO2 burden when providing flexibilities that could be shifted. Importers could essentially bear the CO2 burden. Moreover, accurate estimates of marginal emission factors and not average emission factors matter for evaluating demand-side interventions and integration of renewable energies. If you enjoyed this video, please hit the like button, subscribe my channel, and watch my other videos. Thank you very much.